All right, so this is a continuation of the last video where I just sort of ran out of time trying to prove this result that if W is a subspace of Rn, then the dimension of W plus the dimension of W perp is going to equal n. So the plan of attack again is just really broadly take a basis for W, which I called U1 through UK. Take a basis for W perp, which I called V1 through VL. And then from there, combine these into another basis, okay? And what we're going to show is basically, or into another set, I guess. And where we ended was that we showed this set of vectors here, I'm just going to do dot, 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 these combined set, was an orthonormal set, and like hence linearly independent. And that is nice because it is one of the main conditions to form a basis. So what we're going to try to argue now is that this set B of these vectors U1 through UK and V1 through VL also span Rn. So if they are linearly independent and span Rn, then they are a basis for Rn. And that's going to be our key point, basically. All right. So what I'm going to do is I'm going to say let just alpha be some vector in Rn. We know by orthogonal decomposition, alpha should equal W plus W perp, where W, this vector, is contained in the subspace W, and W perp vector here is contained in W perp, the space, right? That's just some result from last time that we saw, like no matter what, we could always, the easiest one, I'm going to erase this in a second, but I could draw, some vectors as my alpha, all right? And basically alpha could exist, or could be described as this vector plus this vector, right? And this is the one in W perp that's like supposed to be perpendicular. And then this is the one that's like related to that projection computation that we did last time. So so that's true for any dimension too. It has nothing to do with R3 there. It's just the easiest one to draw, of course. So that's nice. And we know W, right, this vector here, can, it is in the subspace W, so it is basically spanned by vectors U1 through UK, some amount of those, right? It can be described by those. And then W perp vector lives in this space that has this basis, right? So this chunk of this vector can be described by V1 through VL, some amount of those, right? And so putting that together, right, we have that alpha can basically, let's say, can be built by a linear combo of vectors in the set U1 through UK and V1 through VL, right? And this means, and this is true because we just picked an arbitrary vector in Rn, right? So this means the set B of that, union sort of those basis vectors spans Rn, right? because we just picked an arbitrary vector and showed that this thing, no matter where you are in Rn, you can get, you can use U1 and U1 through VL, let's just say, to get to some vector in Rn, right? It's going to span it. And so if you put together what we talked about in this video and what we talked about in the last video, right, basically we've done it. So we have that this set B is now a basis for our n. So the dimension of this set is n. But also, the dimension of our n, right, would have to be k plus l, right, because that's just how many of these you have and how many of these you have. So I'm just basically breaking n down by k plus l. And so I'm just kind of trying to connect the dots now. Basically, then dimension of w, right, which equals my k, plus dimension of w perp, which is my l, equals dimension of Rn, which is n, and thus dimension w plus dimension w perp equals n. Whoops. I hit the next button. But that does it. So it's kind of a neat proof. I think it shows some important kind of techniques and whatnot. So I wanted to take the time and fully explain that one. But that is just sort of a intuitive thing anyways, but I think the proof is not so trivial. So I think it's good to go through it. But never lose track of what these theorems are saying. Intuitively, you would want this. You wouldn't expect this to be 2n or something. This is a subspace in here, and if you take that and whatever is perpendicular to it, you should be able to add up to the total amount.